All right, next step is to feed model 2. So we're going to do things a little different in model 2. We're going to do a stepwise variable selection technique to select the variable for us. And we're just going to not include any interactions or any quadratic terms at this point. So we're just going to select just the linear terms. And we can start by letting the stepwise variable selection method to select from a null model, which is a model with no predictors, up to a full model. That means a model that contains every single predictor, just as the one we feed in model number 1. So let's start with the null model, and that is using a GLM and using the target b variable with no predictors. And to have no predictors, you can put a 1 in there, and that basically says is telling the model to train using just the y-intercept. So we are going to do the same here. So that would be our null model with no predictors and only the y-intercept. Up to the full, which we already have feed, so we don't really need to do this step, but just to be complete, let's just put it here. That would be the target b variable using every single predictor, and that is what the dot does, and just on the training data set. Let's see. And the next step is just to do a stepwise method that searches variable significance from the null to the full. So we are just going to start with no variables and go up to the full, checking which variables should be in the model. So we're going to use the step function on that. Let's call this model, let's call it stepwise. Let's call it step dot m2 for model number 2. Right, so we're going to go with the step function, and we say we're going to start with a null model. There's a few things that we have to do here. We have to let the model know from where we are going to go up to where, and that's we're going to say that the lower is going to start with the null model. We have to, just in case we didn't set the formula correctly here, we are just going to use a formula function just to make sure that it is correctly specified. So we have the lower to be the null and the upper to be the full model. So that should basically tell the bounds for the stepwise selection process. We're going to tell the stepwise method to look under the training data set and basically do a stepwise method. So that is the direction in both ways. So we can drop and add. And the trace, you can set it to 0 so that it doesn't print any output while it's looking for a model. So let's run that. And well, this does the variable selection on the background. Let me just say one more time, what we're trying to do is try to see which variables are selected so that we reduce the complexity of the model. Right, so let's do a summary for step model 2. And we can see that some of the variables that were not significant were actually dropped. And we have a much more manageable model here. The p-value for the deviance statistic is of course going to be significant. And at least we only have one variable that is not statistically significant, but it does appear to bring value into the model. So let's go ahead and do the predictions. So just as we did before, let's make the validation. Well, let's do training and validation predictions. Right, so let's call it probability of model number 2. And to do that, we're just going to do the predict function. And this is going to be the validation. This is using the step model 2. And we are going to basically predict the new data to be the validation and the type of prediction to be response. So this would be the validation predictions. So we call it PM2. Let's do PM2 for the training. And that is the predict function on this same value using the data is equal to the training. Remember, we don't have to do new data. This is the data where the model was fit. All right, so now we just want to know AUC values. Okay, so if you remember from the last model that we created, we just got an R1.training and R1.valid. Let's keep that same naming convention so that it's easier for us to just go ahead and compare these values. So let's do AUC values for model 2. So let's say R2 train. So that would be using the ROC function, and that is using the training target B, and we are going to compare that to the prediction of model number 2 train. Okay. So this is going to calculate for us the statistics such as the AUC. So we can take a look at the AUC number. We can see that this is 61.7%. We can do the same thing for the validation as well. And this should be PM2. So we have a validation AUC to be 60%. So if you remember from R1 AUC, this is doing slightly better. So we have 60% compared to 59. Not completely better, but at least we have some improvement in it. So this is model number 2, and the difference between model number 1 and model number 2 is that we did actually stepwise variable selection on this model to have a reduced number of variables, and this appears to be slightly better in separating the responders, the donors versus the non-donors in this data set.